All right. How are you guys going about doing this? What's that? So how, we haven't done this is qualitative data. We've done quantitative data earlier. How do you do it when you have nothing but words or characteristics? Okay, oops. Let's first create a chart. So these are our X. American Express and MasterCard. There's only four of them, right? All right, so now what do we do? Now we do our tally. So as we're going along, on the first row, we have Discover, Visa, Visa, American Express, Visa. Next row, Visa, Visa, American Express, MasterCard, Visa, American Express, MasterCard, Visa, Visa, Visa. So it's 5, 10, 15. So we're on the third column. Visa, American Express, MasterCard, Visa, MasterCard, Visa, Discover, American Express, Discover, Visa, American Express, Discover, Visa, MasterCard, Visa, 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 MasterCard, MasterCard, American Express, Visa, MasterCard, Visa, MasterCard, Discover, MasterCard, Visa, Visa, MasterCard, Discover, American Express, Discover, and Visa. So far, so good. We first have to quantify our data. Now, what do we put? What's that? We have to put the frequency on there. Now we put these into numbers because this is our first checks and balance. How many discovers do we have? Visas, American Express, and MasterCard. So if you add up all those, what do you get? You have 23 plus 23 plus 7 is 11 plus 19 plus 9 is plus 7 is what? This is 30. This is 20. And that's 7. Or that's 20, so it's 50. Yeah, I thought you said 20. Now, why is that an important number? Yes, but how many pieces of data do we have? We have 5 columns, 10 rows. So our N is 50. That is what that is. Our N is 50. Because if they're not equal, then go back and try it again. Then what do we do? So remember, I asked you to find the mean, median, mode. Well, leave those right now because I'm talking about frequencies and variance and deviations. So then what do we do? How do you find the mean?
Which is 50, and you divide by 2.
So add up all your frequencies. Is that just it? That's just 50.
Yeah, and then you divide by 2.
Why
I mean,
2?
not 2, sorry. 5.
1, 2, 3, 4.
No, oh,
We only have 4 groups.
sorry, I was counting 50.
No. This is wrong. Ideally, this is the summation of F. That's what N is. Now, think of what addition and multiplication, how they're related. What is multiplication?
Multiply.
What is it? How do you multiply numbers? A repetition, exactly. So if I had 3 plus 3 plus 3 plus 3, that's the same thing as the number 3 occurs 4 times, 3 times 4. And that equals 12. What do we do with these? Very good. Convert them to numbers. So the number 1 will correspond to discover. The number 2 will be visas, number 3, and number 4. So now what we have to do is we have to take the X column times the frequency. So 1 times 7 is 7. 2 times 23 is 46. 3 times 9 is 27. 4 times 11 is 44. Now we have to add up all those. What does it tell you to do? Follow along. What is it telling you? So that's the beautiful thing about math. It's everything's talking to you right there. And that's why I put the headings up there. So 46 plus 44 is 90. 90 plus 27, 90 plus 7 is 97. 124. So whenever we deal with frequencies, the top part is your X times how many times it occurs. And the bottom is the summation of your frequencies. That is what N is. So we have 124 divided by 50, which makes it what? You have calculators.
2.48.
2.48. Which tells us what?
That's the average.
But what does 2.48 tell us?
Averages, like,
It's Visa. It's at the very upper end of Visa before Visa turns into American Express. Yes, so that's what it tells us. So what's the mode? Our median. How do you find the median?
Take that 2.48 and divide it by 2 since it's even.
No, I see why, but no. Because the median, does it care what values the data is? No, it just simply cares how many there are. So what's the formula for finding the median?
Everything I left divided by 2.
Okay, why 2?
Because that's like, that's half, so it's
Okay, very good. So everything, we mean add up these, add up these, and which ones do we add up? Yeah, so take up the frequency. So take the n, which is the summation of f, and divide by 2. Be 50 over 2, which means it's 25. But remember, if the number equals a non-decimal number, what do you have to do?
That's the 25th location.
It's
You take the 26th location and add it.
Right. We have to find the number in the 25th location and the 26th location and divide by 2. So how do we find that now?
Maybe 25 by 5.
Actually, no. This is going to give us 2. I'll show you why. I'll show you how. Okay, this is a whole new thought pattern we're doing here, because up until now, we've only done with small data sets. Now we're dealing with frequencies. Whenever you deal with frequencies, you have to know where they're sitting. So for the Discover cards, there's 7 of them. Then the next 23 of them are Visas. Then the next 9 are American Express, and the next 11. So that sets them all out. What we have to do is something called cumulative frequency. What does cumulative mean? Everything. A cumulative final is a final over everything. So basically, another name for this is running total. In the first row, how many do we have? 7. Then from 7, we added 23 more. So we have how many? And then from 30, we added 9 more. So we get, and then from 39, we added 11, we get 50. So this is another way we can check to see if our data is correct. You notice how this number and this number are the same, and they have to be. Follow me so far? Everybody follow me? Okay, because now when we find the median, we have to go to the 25th number. The 25th number is bigger than 7, right? But it's less than 30. So the 25th number is in this is called a class. So the 25th number is in this class. What number is it? 2. What's the 26th number? Where is that one located?
Right next to it.
Yeah, it's right next to it. It's still less than 30. So it's also a 2. So 2 plus 2 is 4. So we know that the median is in this group here. That's how we find it using frequencies. What's the mode? That one's easy. It's the highest frequency. Because a lot of people think that statistics is only numbers. These aren't numbers. There are 2 types of data that we have. Qualitative and quantitative. What's the difference? These are numbers. What's qualitative? Very, very good. Excellent word. Traits, characteristics. So now you got that. Give me an example.
What's your favorite color?
Exactly. What's your favorite color? What color is your car? What's your favorite dog? Yeah. So something that's not really numeric, we take it and then we make it numbers like we did here. Quantitative are strictly numbers, only numbers. So that way, these are numbers. Okay, there's a difference. There are two types of numbers. Are blood pressures? Can you find the average of blood pressures? Because blood pressure isn't really a number like 5 inches or 4 feet.
Oh, it's like
It's-
this number over this number.
Yeah, it's because it's a diastolic and it's systolic, but it's more qualitative to that individual. So it's not really, you can't really, in other words, if you have two people, if you have two patients, and one person has a blood pressure of 98.2 and another one has a 99.1, you can't say, I can't add those together and say these two, the average of these two are 97 point whatever. So that's not really, they're not really quantifiable. So it's more of, that's more of qualitative. So it's very, very interesting to think about that. Our temperatures, yes. Our numbers of hot dogs eaten at a hot dog eating contest, is that quantifiable? Yes. Can you find averages? Yes. Now, before we move on, let me look over, I'll show you this. Remember I told you, but the hardest thing in mathematics is, or anything, is to think of something random. In other words, philosophically, nothing happens by chance. Nothing's random. There's a guy named Schrodinger says that just by thinking about it, you've just changed the outcomes. Think about it. And that's become like when scientists go and explore, they're still discovering tribes in the Amazon that they've never seen before. And what these morons do, they go in there and they introduce themselves. The minute they do that, they just influence that tribe's behavior. What they should have done is stay outside the perimeter and just observe them to see how they live, how they interact. How many of you ever watched Star Trek? Okay, everybody fails that quiz. Star Trek Next Generation, they have something called the Prime Directive. The Prime Directive is you cannot go and influence any other life form in the universe. Because just by talking to them, you've now changed them. What if somebody in the Amazon who's lived there forever discovered that we have air conditioning and we have umbrellas? And why is that? Because what happens in the rainforest all the time? It rains, so they get wet. Well, what if we introduce to them raincoats or umbrellas? Now they're not stuck inside their huts anymore. They can go out and move things around without getting wet. In the desert, if it's 114 degrees in the day, and you introduce to them air conditioning, you've now just changed their lifestyle. Believe it or not, it's been happening for centuries by these missionaries that go places and try to build buildings, cities, and schools. The minute you do that, you've just changed their culture forever. It'll never go back to the way it was. So that's very, very, very important when you do statistical research. Really, this. Remember, I asked you, give me 20 one-digit numbers. So, and you can't even give me one without thinking about it. You can't just spit out a number because it has to come through your head first. That's what this chart's all about. To make sure it's totally random, the only thing you can pick is what column, what row do you want to start with? So give me a column number. 2. What row number? So we're starting at 2, 2. So our first digit is 8, then 1, then 3, then 8, then 0. We'll keep on going that way until we get 20 numbers. You influence those number selections 0. Even by picking that row and column, you didn't change it. It's already there. You just told me where to start. So that's how this table is used. Then, what if I wanted, what if I wanted 20 numbers? Do I go across or do I go up and down? Again, that's your choice. We're used to reading straight across, so I keep on going over this way. Or you can further randomize it going this way, if there's any rhyme or reason to it. So that's how this table is used. And I went ahead and gave you also the formulas that we're going through. Oh, I don't know, I forgot to put that in there. Okay. Now, I don't want to do that one just yet. Let's get back to this one. This will be a quiz. I woke you up. Here, brand A and brand B. These are paints. These are the samples of paints. Tell me which brand of paint is better and why.
Because it holds a more consistent weight.
You haven't done any work yet. You just looked at it. Because I'm going to give you something much more difficult in a second. I just want to show you can practice this. Let's do brand B. We'll use this data set for brand B. So here's our data. And we know already that our average is 35. We did, that's the first thing we did. So in the first column we're gonna do what? Yes. Very good question. Does it matter if it's in any type of order? If you're doing median, right? Yeah, because in mode we see everything happens only once. So, but yeah, it's only really important for median because that we have to look at how it's arranged. You see what's in the middle. Great answer. Good question. Great question, actually. So what we're looking at now, since we know the average is the same as the other one, we'll see how far are these numbers away from the average. How do we find that? Subtract, yes. So we take our data, each one of these, and subtract the average from it. You see how far on average is it away from there. So 35 minus 35 is 0. 45 minus 35 is 10. 30 minus 35 is negative 5. 35 minus 35 is, I was wrong. We do have a mode. 35. Then 40 minus 35 is positive 5. 25 minus 35 is negative 10. If we add them together, what should it equal? It should, yes. So 10 and negatives can cancel, negative 5 and 5 cancel, and 0, so it's 0. So that's a good check mark. Then what do we do? Get rid of the negatives. How do we do that? Square the number. So 0 squared is 0. 10, this is 0 squared. 10 squared is 100. Negative 5 squared is 25. 0 squared is 0. 5 squared is 25. Negative 10 squared is 100. Add those together, you get what? 250. Now, looking at this number and looking at the last one, that's a good indication of which one's better. This is smaller, so brand B is a lot better. It's going to give us a better idea when we have to start painting our house again. What this one tells us? Nothing just yet, but it's a smaller number. So what do we do now? We have the x minus x squared. So we look for the variance, which is summation of x minus x bar squared over n. 250 over 6 is what? 41.6 something? So 6.7. It's 0.6666666.
Do you have to round for that one or no? Just put it 6.7.
6, round. I'm glad you asked that. That is okay. It's called the rounding error. Depending on when you do the correction on a calculation, will give you a total different answer. In other words, if we took this number first and if we didn't round it up, and then we took the derivative, the square root of it, to find the deviation. So is there going to be a difference between these two numbers? If we didn't round this one originally, if we had 41.6666666 and we square rooted it,
It's kind of the same.
it's kind of the same, but the more times you do it, the bigger the number is, the more difference it becomes. It's kind of like if you ever went shooting and you have your sight set on something, and just to move just a little bit, even though it's just a very fraction, when it goes down that range, it's going to be more than a little bit. It goes, the further it goes out, the further distance it comes off the target, which is what this is all about. The smaller the numbers, the smaller the difference is going to be, but the bigger the numbers, the bigger the mistake is going to be. So what we're looking at here is the square root of 41 is 6.2 what? 6.45. So brand A has a standard deviation of 17.08 months. Brand B has a standard deviation of 6.45 months. So brand B is better? You said brand A.
I was thinking, wait. Who's the friend A? And it's best so we can go almost a year and a half. Yeah, and then you have to go and retain it.
Yeah, as I say, brand A, you paint it, and a year and a half later, you gotta repaint it.
Oh. Is it, don't you have to paint brand B like 6 months?
Well, in brand, no, in brand B, what it's saying. So I take my average minus my standard deviation. So it's 35 minus 6.45. What does that equal? 28.55. And the other one is the average X bar plus my standard deviation. So it's 35 plus 6.45, which is 41.45. So this one, your house is safe for 28 months. Brand A will start peeling, can start peeling after a year and a half. So which one's better? But this one lasts up to 52. This one lasts to 41. Why is brand B better? It's more stable. You can now start budgeting. You start budgeting for the middle. So between 28 and 41 months, as opposed to 18 to 52. And that's a huge difference. This is a year and a half to over 4 years. I mean, you don't know what's going to happen there.
Oh.
Because remember, what your data originally tells you, this is what the three samples told us. This one goes, the data from this sample went from 10 months to 60 months. This one, look how close they are.
I didn't realize that's what it was saying.
Yeah, this is how they get those numbers, the data set. That's what these months, these are the 6 samples. They opened 6 gallons of paint, painted boards, and put them out in the sun. That's brand A. 6 gallons of paint, painted boards. That's brand B. And they see when they start peeling, and that's when they record them. So even though they advertise last 35 months, let's say it's last 3 years, what they're really not telling you is, you can start before the year's out. It starts peeling. That's not good.
How would it do so well?
Exactly, and that's what people do. And then that's what they say. Well, that's why you shouldn't buy the cheap paint, because the pigments in there aren't just that valid. Okay, let's look at another example, because this one we looked at and we had the same data or the same mean. How about we'll still stay with the brands of paint. Brand A and brand B. Now that you guys know how to do this, 92, 93, 89, 92, 96, 94, 98, 81, 95, 91, 86, 82, and 83. Which brand is better? And why? Group A, what was your average? Group B, what was your average? $88. Okay, now, this is a primary reason why we use the standard deviation. Because what if they're not the same? This is where you compare means. So for the first one, we still have the same process. X minus X bar, X minus X bar squared. So this X bar is 92. So 92 minus 92 is 0, 93 minus 92, 89 minus 92 is negative 3, 0, 96 is 4, 8 is negative 4. Negative 7, positive 7 equals 7. So that's good. So now we square them. 0, 1, 9, 0, 16, 4, 16. That's 20, 30, 46. So we have the variance is the summation of x minus x bar squared over n, which is 46 over 7, which is what? What is it? 6.57. So the deviation is the square root of 6.57, which makes it so it's the deviation we want, not the variance. Because deviation, by its name, how far does it deviate on the average? Now, for the other part of the data, for group B, so we have 98 minus 88, which is 10. 81 minus 88 is negative 7. 95 minus 88 is 7. 91 minus 88 is 3. 86 minus 88 is negative 3 or negative 2. 82 minus 88, 82 is negative 6. 83 minus 88 is negative 5. So we have negative 10, negative 18. Okay, I'll mess up something. 88. So 98 minus 8 is 10. 81 minus 8 is negative 7. 95 minus 88 is 7. 91 minus 88 is 3. 86 minus 8 is negative 2. 82 is 6. 83. So it's 11. 11 plus 9 is 20. That's 20. So it's 0. Good. So it's 100. 49, 49, 9, 4, 36, and 25. What does that equal? How much? 272. Good. Thank you. So to find our variance, we take 272 divided by 7. So the variance is the square root of 38.85, which is 3. So the variance of group A is 2.56, and the deviation is 6.33. So which one's better? Grand A, because the deviation is smaller. You want smaller deviations. Okay, so next week, we're gonna jump into much larger data. Wait, well, even bigger than that, well, no, it could be bigger than that, but yeah, we're using that for random numbers.
Did we do anything with that answer?